If you are here to understand more about artificial intelligence, you're in the right place. When we conceived this session, this was supposed to be starting with the introductory session, and then it's going to be a part two, it was supposed to be followed up with a lab session. So then we started formulating it, realized that in 40 minutes we cannot cover both. So we have split it into two. And I totally understand that some people may not want to do hands-on portion of the work. So for them, we are offering an alternative. After we complete this session, those who are interested, you can join in and we will do a session where you can do hands-on part of the workshop. So what are we going to be covering today? We're going to be talking about digital transformation landscape. This is a buzzword these days. So my intent behind this session was to get you started on the idea of artificial intelligence. The reality is, in next couple of years, this is going to be in everything. Every job function will have a component handled by artificial intelligence. So might as well get ahead of it. I know Prism is a great part of it, but this is not about Prism. This is more about trying to understand the concepts. It's not even about AI sets. It's about AI agents. How do you think about implementing an AI agent? What kind of things should be considered? Think about what tools are existing today. Be aware that these tools are changing so fast. In 6 months, all the tools that I tell may not be the most wonderful, but this is the ecosystem. If you understand the ecosystem, you will see how the evolution of this thing is going to work. What are we going to be covering about understanding Internet of Things? IoT is Internet of Things. Those who do not know that terminology, I would be surprised if there is anybody here who has never heard about IoT. So we're talking about some practical examples. These are what I'm expecting you would get from these sessions. I'm not going to read it all. You're going to have these slides. If you don't have it, please reach out to me. I'm happy to send it over. So we're going to be talking about 3 sections: understanding this AI, IoT, artificial intelligence, and how does these two connect together, and understand about how this AI agent actually works. Let's talk about digital transformation. It's a buzzword. The reality is, why are people so serious about digital transformation? So if you look at these numbers, that will make a lot of sense. It's 1.6 trillion if the devices are expected in just 2025. And average efficiency gain is about 30%. Those are big numbers, right? So that's why people are serious about digital transformation. The only problem is everybody has started to define digital transformation in their own way. If you're looking at digital transformation, you have paper, so you convert them into a PDF, you're digitally transformed, you're not. The concept is digital transformation is very different. So that is why when they say digital transformation, this is what we're talking about, the understanding about the combination of IoT and AI together, which provide these kind of efficiencies that you're really looking at, okay? So with that, let's talk about a little bit history, where it all started. So it all started with about years ago when it all started in Google Labs. They started looking at understanding how human neurons work. Human neurons, if you understand the cell function, each cell, when it connects to another cell, that's a data point is recorded. The concept of neurons, they started, can you mimic this function? So that was the initial thinking of artificial intelligence. And then they built it artificial neural network. That was the initial artificial neural network buzzword. At the time, people were trying to experiment with all kinds of things. Google's entire ecosystem is built around these concepts. Machine learning algorithms came into existence around that time frame. From there, the natural graduation was computer vision, trying to understand, see if we can use vision-based system to do this. At that time, it used to be called a convolutional neural network. It's one of the approaches for vision-based systems, understanding camera systems and trying to understand how vision-based interfaces can be utilized. The natural progression for that was trying to understand natural language that is spoken, written, all of it, right? When you're talking about natural language, it's English, obviously, to start with. There, there are some problems that exist. Natural language is not straightforward. There are words. We're talking about words. So they said, let's see if we can change the words into something called embeddings, trying to understand every word we speak will turn into these embeddings. The concept is now you can think about algorithms that can predict the next word. That was the natural transition of natural language processing and generative AI that we know of. ChatGPT, that is probably the most famous one. Today's generative AI is a lot more than just predicting the next word, but fundamentals of these things is exactly that. This is why I wanted to show the progression of where it all started and where we are now. And from here, the obvious next step is to go towards agents, which is where it becomes functional and usable for the people who are in the actual business of performing business functions. We're talking about convergence of IoT and AI. So why is this important? The three blocks comes into existence. IoT we talked about, which is providing the sensor information. Artificial intelligence, which will provide agents. Yeah, and now we're talking about AI agents, okay? And then the kinetic. So think about it this way. The IoT providing current sensor information. The traditional, any sort of large language model doesn't have facts. It has a model. The facts have to be augmented from your ERP. But you need somebody to do those things. That's the major problem many people face today with ERP. You provide a dashboard, then you need a user to act upon that dashboard, do something. So that is the part that AI agent actually solves. So in these three things together, that becomes a for continuous feedback loop that actually enables functions that make this not just the ERP, but the entire system work like a complete digital feedback loop, right? That's what it provides by this convergence. We have to look at business value proposition. What is the business value proposition? You must have heard all of these three buzzwords, right? Operational excellence. You're talking about agile decision making. I'm sure these three words you have heard it in many presentations. But what are we talking about? We're talking about reduce the downtime, improve productivity. And those things make sense, right? The agile decision making. What does that even mean? It's a faster decision making or understanding of the data to make a faster decision. Cost optimization, reduce waste, reduce. So all of these things is what we are relating. The business value proposition is pretty straightforward. A self-optimizing business ecosystem. That is what the promise of this technology is, right? With that, we'll get into understanding IoT and AI integrations. When we talk about IoT, Internet of Things, people only understand in terms of sensor. What is a sensor? A temperature sensor, which is a small electronic that does sense a temperature, sense a voltage range that turns into a temperature. But that's not it is. The IoT, Internet of Things, means the entire ecosystem around it. It has to be the applications is an important part. The connectivity portion is important. Beyond just sensors, even the processing capability of these, the data that you're seeing, all these things. Together is what we call it as IoT or Internet of Things ecosystem. Okay, so even the connectivity of, are we using Bluetooth or are we using cellular? So these connectivity mechanism combined with your processing is what make this the complete, what we're talking about, Internet of Things. All right, moving on. What is an AI agent? There's a lot of confusion around AI and AI agent. So the simplest way to think about an AI agent is like this, right? You all know ChatGPT. You ask a question, it will try to give you an answer. That's as simple as that. AI agent is something different. It is not a large language models. Every agent operates within an environment. Environment is the domain in which it's operating. That is the guardrails that we're talking about. Then you're talking about the input that you provide. This is probably your prompt. When you type something in, that's called a prompt. The agent is working in an environment. It's perceived the what and makes some decisions. Makes a decision. And then it also learns. The basic way to understand this is the agent has autonomy. It is offered Within the constraints of what's offered, it is provided a prompt and it is expected to do something. The goal is defined. How to accomplish that goal is not defined. That's where it becomes scary for people in application development. I can tell you these are the 5 steps you should do. This goal, how do I accomplish that that the algorithmic thinking that we used to have, we traditionally application developers have, is very different. This is about getting control of how the agent functions. This is the change in paradigm in how we think about application process. So this kind of, it summarizes what an AI agent is and how it works. Moving on, when you say AI agent, it is not just one type of agent. There are a range of motion for that matter. So say, it could be as simple as, we call it the reflex agents. You guys are familiar with regression model. AX plus BY is equal to C. That is still, you're trying to predict something. You are trying to program this to do a specific activity. If it is well defined, your actions and rules are defined, it is closest to something called a bot. You define the rules that the bot is supposed to do. That is the reflex agent. On the other side is the learning agent. In between, there are several of the model-based agents, goal-based agents, utility-based agents. So the key point in this, what I try to highlight here, the first one is about clearly defined rules. Second one is about understand the state of environment. The third one is about predefined rules, right? And the utility is when you're talking about very clearly defined utility, or a self-driving car, or any specific utility that this agent is supposed to do. The last one is about if you're trying to learn along with it, that's the learn. It is, you make a failure or a success, and that you learn, and the agent will learn next time they operate. So this is a range of the different type of agents that exist. Now, if you're talking about any sort of artificial intelligence, it is important that you understand at least 2 classes of learning: supervised and unsupervised learning. We're talking about that these are some of the algorithms. So the goal is predict outcome based on past examples. So that's the supervised one. So learning. The other one is about unsupervised. Unsupervised is you're trying to uncover patterns that exist in your data, right? So the algorithms that are listed below are the kind of algorithms. If you have not heard about it, don't worry about it. These are traditional algorithms, but this is the usage of this kind of explains if you're talking about anything to do machine learning. If you are working on a project, you may want to ask, are you talking about supervised learning or unsupervised learning? What are you planning on using? So you should ask those questions to people who are building this. Then we talk about AI agents and business workflows. We're talking about anomaly detection, predictive analytics, process automation, and intelligent assist. This is how I classified it in terms of a broad categorization. Below that, I explained the potential benefit you can derive from each class of workflows. So if you are thinking about what kind of workflow you're trying to implement, then this is what it is, right? Whether are you trying to detect a problem, a defect, or what you're trying to accomplish with these workflows. For example, predictive analytics may have about 30% benefit. And you're talking about process automation, it can go up to even 60%, 65% reduction in manual processing. The agents could work a lot more efficient than potentially using a human being. Now, let's try about connecting IoT to Epicor and Kinetic. How does that even work? IoT integration architecture is what we're talking about. Here, on the top level, this is the IoT devices. Then you have an IoT gateway. This deals with all the sensors and the interactivity and connectivity. Then there is the integration layer, generally a middleware. Epicor is a fantastic tool. Some people, at least a smaller segment, may just get rid of the middleware. Not ideal, but it will still work. You can still directly connect through API layer, through Kinetic. But the architecture is something like this. So it's better to use a middleware because it does provide a lot more benefits to implementing such projects. Now, if you're implementing AI agent-related projects, these are the core 5 steps that you would want to think about. Assessment and planning. This is pretty standard, but there are a few quirks there, which basically means that it is very hard to determine the end goal of saying. So people will say, okay, this project will determine, save X amount of money. For these kind of projects, it's a little hard to determine that. So be aware of that risk factor. And plus, you have you're dealing with large language models or small language models. There are a lot of failure points. So that is why this very having a clear understanding about how the assessment becomes an extremely important portion. Then the equally important part is the infrastructure setup. Without this, nothing will function anyway. There are too many connection parameters that could go haywire with these things. We're talking about integration and development. This includes even scenarios like retry, right? What do you do in that kind of scenarios? All of these logics needs to be built. Your connectivity needs to be tested. So testing and validation, I cannot stress enough. This is extremely important. And deployment and monitoring. AI agents needs to be monitored. This cannot just let it go because there are too many things that can go wrong if you're not constantly monitoring. Deployment includes monitoring. That's extremely important. We're talking about the third segment here, which is AI agent in action. So we started with the understanding about AI, the IoT function. When we started discussing about what an AI agent does, now we're talking about converging these three things together, right? How do you really accomplish that? AI plus IoT plus Epicor. Together, Epicor Kinetic has the business context. It has the data around your sales orders, your customers. The business context is available only within your ERP. And the agents can operate on that. What's happening right now on the floor, that's what the IoT will give. So add these three things together. You're converging all these things together when you are actually able to leverage some of this key concepts and the context, business context that it's able to offer. Now, in terms of tools, these are the major tools that exist among the oldest one. So traditionally, there were, when OpenAI came up with its ChatGPT tool, there was also Llama that came up from Facebook. Llama 2 equally viable or even better in some instances. The key thing was you can run it on premise if you want to, if you invest in their hardware. Now, today's it's all about DeepSeek. So that's another alternative. You could absolutely run on premise. People are scared about China factor, but the fact is you could run it locally. Then it will provide equally reliable results as you can think of. The point here is this is not about the models. These tools came into existence to enable AI agent development. LangChain is probably the most famous one. Then there is the Llama Index, there is LangFlow, and a few other tools. One that you see on the box is mostly from Microsoft. Semantic kernel is actually still, Microsoft is seriously pushing it, but I personally not my great favorite. AutoGen is another one that started in the Microsoft research labs. This gentleman started it and then decided he doesn't want to work for Microsoft. He went to Google and Microsoft said, we're going to just continue building it. And Microsoft is continuing to build further on AutoGen. In addition to this, there is things like artificial AI bot service and other Microsoft. If you are seriously invested in Microsoft stacks, these are the tools that you have to work with. Understand this thing involves Python, right? It's not C#. So this is a different world. The rest of the tools are also built around open source ideas and slightly non-traditional thinking of application development. So let's talk about one of the simplest example. I'm taking this example of AutoGen, but all the other tools will do something very similar. You start to define agents. Let's say the requirement is that you need to write a children's story. You say, Agent 1, write a story. Agent 2, verify that there is no profanity in it, that this is age appropriate. You define certain constraints around it. Agent 1, do this. Agent 2, verify that this is correct. And have some sort of way of talking to each other. This is what we are talking about, checks and balances, right? And in the simplest form, we're talking about something like an Agent 1 and Agent 2. Agent 1 does certain functions, Agent 2, certain functions. They collaborate and then complete a task. You can convert this, things like tools like AutoGen has even a no-code option that you can build these conversable agents very easily. You can build these orchestrations that Agent 1 will do this, Agent 2 do this. And how do they talk to each other? What kind of hierarchical information? So you can organize it a certain way. There is a way to communicate between these two. This is AutoGen, just one tool. I have not gotten into the details of the other tools, but I want to give you one. When we initially conceptualized this was very new, but now it has become very prevalent. I had to put in a segment about model context protocol. This is a new protocol for helping different agents to work together. In the simplest form, any prompt has only two or three things, right? You have the text. What is that you want the LLM to do? You have a parameter that says temperature, which is your level of randomness. You are feeding it tokens, and then it's going to give you the results. So this model context protocol came from Anthropic, but this is doing this process of where is this agent running? What is the prompt you're supposed to send? And then what do you expect? The is JSON RPC 2.0. It's very similar to, think of it like this. REST API is the simplest tool that was available when the web development came into existence. NCP is something like that. Model Context Protocol, if you look here in Google or search for it, you'll find there a lot of interest and discussions around Model Context Protocol. It is becoming standardized. These models are able to work together. Regarding Prism, I don't think they have made a clear decision yet. Are they going to follow MCP or not? They are also developing it so fast. So it's possible that in future we will have maybe some combinations of it within Prism. If some of it you could leverage in different agents, some of it you could build your own small microservices, and so you provided the data context in a way that you can utilize. So that's going to be a big deal now, right? Prism is fine. But as you start using it, people are going to use a lot more tokens. So that becomes the big cost concern. Right now, all the major players are concerned about the cost. The cost of running these LLMs are starting to grow up, and they will, at point in time, they will pass on that cost. So we need to be ready for that. And hence, we need to think about how do you simplify your model? How do you have a bit better control over this? This is why these things are important. Agent in action, and there are a few cases. We are talking about something as simple as quality control and compliance. This is the kind of business impact you're really talking about. If you're talking about this, 60 to 70% reduction in quality escapes. I don't have to tell you what that means. You guys are all from manufacturing background, so you know what that means. And you can directly calculate the direct impact or something like so. This is the other thing, right? You're 50 to 70% reduction in documentation. See how much it will reduce in terms of your manual work that your people are doing on the floor today, even reducing the cost. This is a technology you cannot get away from, and we will have to seriously, there is no way you can avoid it. Today or tomorrow, your executives are going to hear these statistics and come back to you. How do you implement it? Figure out your strategy to do this. Make it happen. So be prepared for this. This is coming. Then these are all real numbers, right? If you're talking about implementing something like this, you do need a roadmap. Many of these things fail because people say, go to one of these AI classes somewhere, and suddenly in 2 weeks, I can put together a prototype. And then they say, put it on production and make it run. It doesn't work that way, right? You need proper planning, assessment and planning, then put a pilot in place and scale and optimize. You could fail in any of these components if you're not doing it correctly. So be aware of the things, these failure points in these kind of projects. Your executives may not know this. So highlight, if you are thinking about these projects, the failure risk is there. Be aware that these things are not as straightforward as go to ChatGPT and ask for stuff and it will get, or Copilot that Microsoft is providing. It is not like that. You're talking about the ERP context, and you're talking about tons of things, including the most concerned people I have is about security. How secure is my data? Am I worried that all my data is going into LLM? That's one of the big concerns many people have. Is LLM going to learn out of my data? The reality is models are already built. Models doesn't need to learn from your data. There is another concept called retrieval augment generation. You're not sending your data into LLM. You would structure the prompts and then utilize the data that is available in your documentation, in your ERP context. It will format the text in the way you want. That's the core concept I wanted to discuss. This is where I said that there's a part two. If you are interested, I would suggest you enter this information. This is just a Google form so that I know I need to reach out to you. When we schedule it, I would love to invite you all to come in. You're going to need some of this microcontrollers. So this is what I have few of them to show you guys what we have here, what we need. These are ESP32 microcontrollers. You're going to need this to do this demo. So either I can ship it to you, or if you choose to purchase it yourself, you can, but you're going to need this for doing the second part of the demo. If you can let me know, we'll go from there. With that, I will conclude, and I would love to answer any questions people have. This is a great time to pause and take any questions. Either I did a wonderful job or I did a terrible job. Please fill up your feedback. Thank you again. If you have questions, I'll be around. Thank you.